So we finished almost all the chapters, all 7 chapters, and this is our 8th chapter, and this is the final chapter. And after this, we'll be discussing the question answers. After we complete this chapter, then we'll be discussing the questions and answers. Okay. So electricity. Now you all know what electricity is, isn't it? At least you have the idea. So you see around, you see electricity everywhere. Like the bulb, TV, everything is related to electricity, and it plays a very, very important role in our life, isn't it? If there's no current, if there's no electricity, so, and if it doesn't come for like 2 days, we kind of start panicking, isn't it? We tend to be very restless. So because it plays a very important role in our life, it is a very important aspect of our life. So we are related to it in our day-to-day life, and without it we cannot imagine our life. That is why we need to understand what electricity is. So electricity, and this is page number 132, chapter 8. Okay, so all those who've been referring to their books, please check page number 132, chapter number 8. So electricity. So the beginning over here. So we all are very much familiar with the term electricity, everything related to it, how, and some of you might be knowing also, isn't it, about a little bit about electricity, how the current flows, what makes the current flows, isn't it? So let's discuss about this. And before we jump into the, how the current electricity is produced, before we come to that part, let us discuss the important aspects. So, all the elements, they are made up of molecules. Molecules are the smallest part of an element, isn't it? Which you have learned in chemistry. But then molecules are further made up of atoms. And atoms are considered the tiniest particle which combine to form molecule, and molecules combine to form elements, and elements combine to form compounds. So first let's discuss what is an atom. So atom, when it is further subdivided, it has 3 fundamental particles, the 3 important particles of an atom. That means atom is made up of these 3 particles, which you, I'm sure, very well know about it and have already learned this in chemistry. They are protons, electrons, and neutrons. So let's revise this. Okay, so an atom have all the 3 an atom have 3 particles, 3 basic particles. They are protons, neutrons, and electrons. So electrons revolve around the protons and neutrons, and protons and neutrons together, they are called nucleus. So we say electrons revolve around nucleus. We don't say electrons revolve around protons and neutrons. We say together, we say nucleus, where protons and neutrons stay together. It's called nucleus. So protons are positively charged particles. So all these particles, these electrons, protons, neutrons, protons and electrons are charged particles, whereas neutrons are neutral particles. So electrons, as you know, electrons are negatively charged, which means the charge of electron is negative. Protons are positively charged, which means the charges of protons are positive, and neutrons, they are neutral, which means they are neither positive nor negative. Okay, so neutrons are neutral, so they are neither positive nor negative. So we have electrons, protons and neutrons. Now why are we learning about this electrons, protons and neutrons? Because it is the movement of this particle, it is the movement of the electron that produces current. That means that generates electricity. So in order to understand that, first we need to know this basic terms. Okay, to get into the detail about electricity. Before knowing about electricity, we need to know about electrons, protons and neutrons. And as I told you that I'm sure that you people very well know about protons, neutrons and electrons in your chemistry class. But however, I'm just revising it. So, electrons are all negatively charged, protons are positively charged, neutrons are neutral. And the charge of electron and the charge of proton, generally what happens is an atom is considered to be neutral. Now why is an atom considered to be neutral despite having positive charge and negative charge? It is because the positive and the negative, they neutralize each other, which means the number of protons and the number of electrons are generally equal in a stable atom. Okay, so they neutralize each other, and moreover neutrons are already neutral, so atom as a whole is considered to be neutral. So so that is all we have, and you know that electrons are the ones which move around protons and neutrons, which means nucleus. Okay, so these are the only basic terms before we jump into electricity. So electrons, protons and neutrons. Now we'll be moving on to electric current. Now when we talk about electric current, Now when we talk about electric current, it is actually the movement of electrons that produces or generates electricity, or that produces current. Okay, so current is induced by the movement of electrons. That means your negatively charged electrons. Now why electrons? Why not protons? Because you saw the structure there. Protons are inside the nucleus. They are not free to move, whereas electrons are the ones which are free to move around, and that is why the flow of current is it depends upon the movement of electrons. Okay, so when charges shift from one body to other, the bodies are said to be charged. In fact, the free electrons of an atom are transferred on account of the friction or by rubbing of two bodies. So when you rub two bodies, there will be flow of charges. Okay, and when we talk about flow of charge, it is the movement of electrons. Okay, so when we rub two bodies, so one gets, what happens? The electrons transfers from one body to another. So when there is a transfer of electrons, current is produced. Okay, so you might have experience in your day-to-day life also. When you rub scale on your hair and you just continuously rub it on your hair, what happens is the charges flow. Okay, the charges flow between there will be flow of charges. When I say flow of charges, it means flow of electrons between the scale and the hair. And that's why when you bring the scale down and when you try to pick up the papers get stuck with it tries to stick to the scale, isn't it? Because temporarily the scale has been charged by continuously rubbing it with the hair. Okay, so every time there is a friction or when the two bodies rub with each other, there will be flow of charges. So when charges move or flow, we get an electric current. So electric current consists of movement of negative charges, that is electrons. So the flow of electrons gives us electricity. It is called electric current. So what is electric current? Electric current is defined as the movement of electrons. Okay, so electric current is produced by the movement of electrons. Okay, so electric current is produced by the movement of electrons. Not protons or neutrons, but electrons. So how do we define electric current? So we define electric current as the rate of flow of charges in a certain time. Okay, so electric current is defined as the rate of flow of charges, in a certain time. So this is how we define the current. Current is defined as the rate of flow of charges in a certain time. And how do we write it mathematically? We write it as I represents current. Okay, I symbolizes current. Q divided by T. What does Q represent? Q represents the amount of charges. T represents time. So where Q is amount of charges, T is your time, and I is your current. Okay, so this is the mathematical expression of current. So how do we write the formula for current? I is equal to Q by T. And what does Q stands for? Q stands for amount of charges. What does T stand for? T stands for time. Now from here we have to find the SI unit of current. So before we come to the SI unit of current, let us discuss the SI unit of charge. The SI unit of charges is coulomb. The SI unit of charges is coulomb. The SI unit of time is, you know very well, second. Okay, so from here the SI unit of charges is coulomb and the SI unit of time is second. So from here, what do we get the unit of current as? Coulomb upon time. So we say coulomb per time, or we can also refer to it as ampere, capital A. Okay, symbolized with capital A. So what is the SI unit of current? So the SI unit of current is ampere. SI unit of current is ampere, capital A. Okay, and there are other units of current as well, and the other unit of current is milliampere, which is used for measuring very small amount of current. So when we are referring to very small amount of current, we call it milliampere. Okay, we measure it in milliampere. And the relationship between milliampere and ampere is 1 milliampere is equal to 1/1000 ampere. It is that less. Okay, 1 milliampere is equal to 1/1000 ampere, which is equal to 0.001 ampere. So this is the relationship between milliampere and ampere. And we do have numericals related to this mathematical expression, which we're gonna do in the next class. Okay. So if you have any doubt, any queries, please do ask. Thank you and have a good day.